afternoon to everyone. My name is Vivek Pandey. I'm Senior Solution Architect at ZETTASCALE Technology. So today I'm going to talk about optimizing RAS2 communication using RMW. So RMW Zenoh is high performance RAS2 middleware for scale and efficient robotics communication. So I would like to tell a story. One of our customers who adopted DDS for their robot communication. During development and lab testing, everything worked well. So the system passed the functional test, simulation, and even and initial testing. But at the time of deployment, the things was not working. Some of robot stopped discovering, and for the big messages, big data stream, just like images and points cloud, so they cause the latency spike. So it was very difficult to debug this type of complexity and this type of issues. So what we learn from this from our users, so the system may work into the controlled environment, but at the time of deployment, it may or may not be scalable. So for that, we have to find out the right solution for that. So before dive into the RMW Zenoh, we start with the basic of DDS. So DDS was chosen for good reason. So because earlier it was the middleware for only middleware into the RMW Zenoh. So it was chosen for good reason. It support the peer-to-peer communication. So there is no broker in between, and it is the standardized by the OMG. And there are many vendors and open source implementation available into the market. And it is proven into defense and aerospace, and it works well on wired, fast, and controlled network. But for the modern robotic systems, it have some challenges. So first challenges is in discovery, because DDS highly rely on the UDP multicast. So in that, each and every participant send the discovery messages and listen all the discovery message from all the participants. So when the participant increases, the number of messages increase into the quadratic way, because the complexity is big O n square. And DDS was not meant for the large payload handling. So because default UDP kernels doesn't optimal for the image and points cloud. So you need to tweak at the kernel and OS level. So it is not well suited for large payload handling. And out of experience is not too good. You have to configure too many parameters to enable your communication. And DDS was not meant for the deployment like container, firewall, and VPNs. So you have to configure many things. So it is very difficult in this scenario. So in short, we can say that DDS assumed controlled network, while modern robotics operates in dynamic, distributed, and cloud environment. So now we step back into the RAS2 communication stack. So RAS2 provide a modular architecture where for the communication, user application uses the RMW middleware wrappers. So underneath, it uses the middleware provided by just like Cyclone DDS, Fast DDS, and now Zenoh. So come to the RMW Zenoh. It is a RAS2 middleware based on the Zenoh protocol, what Angelo already explained in details. And for this RMW Zenoh is written into Zenoh CPP. So we use the Zenoh CPP for this. And it is tier 1 since tilted Kaiju. Because it is tier 1, so it is available into the core RAS2 packet. And by default, RMW Zenoh uses the TCP for discovery and other transport. So what in the morning you have already seen that there is no topological constraint with Zenoh. But for this RMW Zenoh, we use the TCP for discovery as well as transport. But it is not limited to TCP. You can configure the UDP peak and serial and so many. RMW Zenoh provide the hope-to-hope reliability. And what the problem was in DDS related to quality of service mismatches. So here we don't have such type of problems. So in default topology, all the discovery is done by the Zenoh router, and all the data communication is done by the peer-to-peer. And discovery is local to the local host. So now come to the RAS2 primitive and Zenoh abstract mapping. So for encoding, Zenoh support different type of serial encoding, not only the CDR, but for RMW Zenoh, we rely on the DDS CDR. And RAS2 have the publisher subscriber. So we map that with the Zenoh publisher and subscriber. For the service server and client, we map with the queryable and querier available into Zenoh. For RAS2 action, so it rely on the 3 services and 2 topic. So we map 3 services with the 3 queryable, and for 2 topic we map with the 2 publishers. For the parameters, still mapped by the RCL services. So with Zenoh, we map with the queryable. And Zenoh have a concept of liveliness token. So you can assign the liveliness token with all the DDS entities. So for entity discovery and RAS graph, we map with the Zenoh liveliness token. So because Zenoh don't have any topological constraint, so why a Zenoh router is required? Because Zenoh support the peer-to-peer communication, brokered communication, routed communication, client-server type of communication. Then why router is required? Because we have seen a lot of problem using UDP multicast. So for RMW Zenoh, we are not going to use. So no UDP multicast, because it need tweaking at kernel level and OS level. So it creates some misconfiguration issue. And if you use the UDP multicast, then there is an accidental communication across the external world. So we prevent that. And for discovery, we use the gossip protocol. So all the nodes connect to the router and share their locator, and router share the locator to all the node to other nodes. Now come to the external communication. So what the router help with the external communication. So because for the external world, we configure the router to do the discovery and all the communication. So there is less connections, so less overhead. And for the small messages, it do the automatic batching for the better throughput. And because there is only one point to expose the external world, so it have the small surface of attack, and you can impose the access control, downsampling, transparency, and compression, shared memory, all the things you can configure at the router level. In RMW Zenoh, we have some default configuration. So you can use the default configuration and you can establish the communication. So by default, there is no UDP multicast, and all the communication and discovery will be done by the TCP over loopback. And for discovery is done by the RMW Zenoh, which is the Zenoh router. And Zenoh router listen all the available interfaces. So here you can see we have the default configuration for the router as well as for the other nodes. So we have two configuration. One is for the router. So it is called default RMW Zenoh router config.json file. And for the other nodes, we have the default RMW Zenoh sessions. So you can configure so many parameters, but here we focus. We have snippet for the connectivity. So you can see the by default the router doesn't connect to other external endpoints, and it enables the gossip protocol for the discovery, and it automatically connect to peer connect to the router as well as peer. And other node sites, so node connect to the router. So here you can see the endpoint TCP localhost and port 7447, and it listen on the local host, and the port is assigned by the operating system, so it is 0, and it enable the gossip discovery protocol, and peer can connect to the router as well as other peer for the data exchange. So this is you can see that this is the standalone robot where there are many nodes that are connected to the router for the discovery, and once discovery is done, then all the nodes do the communication in peer-to-peer way. So one of the question I have seen that someone written some question that if Zenoh router is stopped or crashed, then what if the communication will continue or not? So Zenoh router is required for the discovery. Once discovery is done, then if router goes down, then there is no effect on the communication. Communication is continuous, so there is no problem into that. So far, if you want to connect your robot to other robot or other external world, then you can override the default configuration. You change the default configuration. So for that, we have two environment variable. One is Zenoh router config URI and Zenoh session URI. Router config URI for the router and session config URI for other nodes. So you can change the default configuration file, and you set these configuration variables, and you can continue your communication. And we have other environment variable. So by using that, you can define that into the command line. So you can straightforward set the configuration. So here you can see that we have a robot, and we have some controller. It may be your laptop. So in that laptop is running the Zenoh router and other tools like Rascally, RWIZ, teleoperation, RQT. And if you want to connect to this laptop or controller to the actual router, then you have to set the connection endpoint. So here the router have the 192.168.1.2. So we set this configuration. We are not changing into the configuration of a default configuration file. So you can do that also. So here we set that, and we restart the restart or restart the router. The communication will start. So here you can see that at our controller side or in our laptop, we are running only RWIZ 2. So if this router is required, so the answer is no. There is no requirement of router. So you can directly connect your node to and set the endpoint, and your node directly connect to the robot. So here we have the scenario of the fleet connectivity. We have the fleet manager, and there are many robots that are connected to the fleet manager. So you can do into two different way. There are two possibilities. One is your fleet manager connect to all the router. So because your fleet manager router is connected to all the robot, so you define all the endpoint into the fleet manager router. And the second approach is you your router, sorry, your robot connect to the fleet manager. So you can define the endpoint into the your robot. So you can do into the both way. What if you enable you want to do the automatic discovery at the router side? So you can do that. So for that you need to enable the scouting. So nowadays the robot have different hosts. So here you can see that we have MR and we have the robot arms, and it is connected to the Ethernet. So the better thing is you run the router at the MR side and you configure all the nodes, listen on the Ethernet port, and your ARM node connect to the AMR. So you can see that AMR side the configuration is this, and robot ARM side configuration. So you can use that. So now come to the optimizing RAS2 communication in terms of performance, reliability, and security. So for performance, you can configure the shared memory, you can do the compression, you can the downsampling. For the reliability, you can use the priority, you can set the congestion control. At the security level, you can use the mutual TLS, or you can use the ACLs. So here you can see that how we share how we configure the shared memory. So by default, the shared memory is disabled. So you need to enable that by using the shared memory enable true. And it provides the zero copy delivery for the large messages. So if your shared memory is not available, then it automatically fall back to the TCP. So if anyhow there is your shared memory is not allocated, or there is a problem into that, so the communication will fall back to the TCP. And if you want to use the shared memory in two container, then you can do that, and you can define the minus IPC is equal to host, or you can make a common volume / dev SHM, and it have the automatic garbage collection. You can do the defragmentation and all the cleanup. You can do the compression, because Zenoh provide the link level LZ4 compression, and there is no need to change into the configuration. You only define into the configuration. There is no need to change the code. And you can do the downsampling if you want some topic, but with lower frequency. So you can see here we have key expression, camera image. So we change the frequency to Hertz. So you can do that. And for the priority, because RMW Zenoh doesn't allow the priority configuration, but with the RMW Zenoh or Zenoh, you can do that. You can define the priority at the key expression level. You can define the congestion control. It is very, very important because sometimes if your queue is full or system is highly loaded at the time, you confirm that for the priority data and other data to send. You can configure the security by using the MTLS. So here you can see that we define all the security stuff. We generate the certificate. We get the private key. We configure all the things, and we ensure that for the trusted communication. You define the access control. So you can let your router to allow or deny the data forward or incoming data. So you can do that. So here you can see that. So we have different routers running on the factory floor, and our other router is running on the cloud, and we configure the transport layer security. So by using that, you can connect the world. What is the key takeaway? So Zenoh provides a unified high-performance communication layer for RAS2. It provides the shared copy for zero-copy transport for image and points clouds. You can define the priority congestion control to ensure critical commands always get through. You can do the compression, downsampling, optimize the Wi-Fi and cloud communication. You can define them TLS, ACL for the secure and authentic communication. And you can simplify the multi-host fleet and cloud robotics deployment, anything you can do. And we are going to run a workshop on Saturday. So if you want to learn more, then you can join that. Thank you.